Hello and welcome to our last video for the department's May 2023 paper 1. Last video for now. I think I forget to emphasize that if there's any content that you want to see, if there's any question that you want to see covered, feel free to reach out in the comments and I will make the content. If you want me to go over a question that I have done a video for and you just feel like it's not hitting the spot correctly, I will definitely try to make another video, possibly explaining maybe from a bit further down in the foundations or looking at it from a different angle and so on. So key thing is for you to ask and you shall receive. Anyway, so the last question in our paper 1 is a counting question. I just love counting. So 10.3, 7 friends, 4 boys and 3 girls want to stand in a straight line next to each other to take a photo. In how many ways can the 3 girls stand next to each other in the photo? Okay, so for questions like this, I think it helps to think about, okay, here's boy number 1, boy number 2, boy number 3, boy number 4, and then the ladies. Okay, right, and we want these ladies to move together, right, in our counting. So we're not interested in arrangements where they are separated, so they have to be in a block. So in fact, this question is not asking us to arrange 7 people, 7 items per se. It's actually asking us to arrange 5 items, in the sense that, okay, boys, they can stand anywhere they want, but the girls travel in a group. Okay, so it's either we then have boy, group of girls, and then the rest of the boys, or we could have boy 1, boy 2, group of girls, boy 3, boy 4, and of course we could swap boy 2 and boy 1 around, we could swap boy 3 and boy 1 around, and so on. So the arrangements are coming from mixing up these 4 boys and this group, and the group of girls is one item. So we know then that, okay, in position 1, we could have one of 5 things. It could be boy 1, boy 2, boy 3, boy 4, or the group of girls. And then in the second position, we're only left with 4 options, and so on, right? So there's 5 factorial ways that we can arrange the boys and the group of girls. Then the key thing to remember as well is that within the group, we could shuffle the girls to give us a different arrangement. So we could have an arrangement where we've got boy 1, boy 2, boy 3, the group of girls, and boy 4, right? And within that group, we could have girl 1, girl 2, and girl 3, right? Or we could have the exact same arrangement, no, except it's not the exact same arrangement for the boys. Okay, so we keep the boys where they are, but then the girls, we mix them up a bit. So we have red girl first, and then green girl, and then orange girl, right? And we could do that again, keep the boys in the same position, but then the girls, we start with green, and then orange, and then red, right? So within the box, there are 3 factorial ways for us to arrange the girls, right? Because in position 1, there's 3 girls we could choose. Then for position 2, we're left with 2 girls that we can choose from. And then for the last position, there's only 1 girl left that we can choose from. So, right, there are 5 factorial ways for us to arrange the boys and the group as an item. But then for every arrangement that we have in the 5 factorial, there are 3 factorial ways that we can arrange the girls within that one arrangement. And so our answer ends up being 120 times 6, which is 720. Okay, so let's just check that I have spoken sense. Otherwise, I must correct myself right here on the spot. So yes, we are in agreement with the memo. Okay, so time to shrink stuff. Okay, right. Next question. Next question says, in the next photo, determine the probability that Selwyn and Lindiwe will not stand next to each other in the photo. Okay, right. So a very specific boy, a very specific girl. Okay, so with questions like this, right, it is often easier to count the opposite of what you're being asked for first. Okay, so what do I mean by that? So if we want to think about all the ways that Selwyn and Lindiwe don't stand next to each other, we'd have to think about, okay, Selwyn in first position, and then someone else, and then Lindiwe is possibly here, and then 5 other people. So that would be one possibility, right? 1, 2, 3, 4, 5, 6, 7. Okay, messed up my counting somewhere. 4 other people, sorry. Right? Or we could have Selwyn here, and then 2 people, and then Lindiwe, and then 3 more people. Or we could have Selwyn here, and then 1, 2, 3, Lindiwe, 1, 2, right? And then from there, so we could do that, and then there's a possibility that, okay, it's someone else in the beginning, and then Selwyn over here, and then 1, and then Lindiwe, and then, right? So there's lots of combinations that you'd have to consider if you were to count, okay, how many ways can this happen directly? What's easier to do is, and it's kind of been hinted to you in the first question, rather count the complement, right? So in how many ways can Selwyn and Lindiwe stand next to each other, right? And then we figure out, okay, how many arrangements are possible in general, and then we subtract the number of ways that Lindiwe and Selwyn, the arrangements in Lindiwe and Selwyn are standing next to each other. Then we know that the remaining number of arrangements is ones where Lindiwe and Selwyn are not standing next to each other. So let's start by saying, okay, total number of arrangements. So we don't care about who's standing next to who. We're just saying how many arrangements are possible. And that is 7 factorial, right? So for first position, we have 7 people that we can pick from. For the next one, we have 6 people we can pick from, and so on, until we're just left with 1 person to pick from for the very last position. So there's 7 factorial different ways that people can be arranged in these photos. Then we're looking for number of arrangements where Lindiwe and Selwyn are next to each other, right? Because then we can think of them as a group, and it's a lot easier to count. Are next to each group. Oh, multitasking. Are next to each other. Okay, so that's what we're going to count next. So remember, then we're thinking about person, and then Lindiwe and Selwyn, and then 3 more people. So that's 7 people. 1, 2, 3, 4, 5, 6, 7 people. Okay, right? So Selwyn and Lindiwe are moving as a group. So that means actually we're counting 6 items. We're counting the 3 other boys, the 2 other girls, and Lindiwe and Selwyn as 1 item. So there are 6 factorial different ways that we can arrange them, right? For position 1, it's either we put in one of the 5 other kids or the group, Lindiwe and Selwyn. And then position 2, it's either, whatever we're left with 5 things to choose from and so on. So it's 6 factorial, okay? And then remember that for each arrangement, for each of those 6 factorial ways that we could arrange the other kids and this block, this group, we could also move, Selwyn and Lindiwe. We could swap them to create a different arrangement. So that actually doubles the number of arrangements that are possible, right? So if we've got boy 1, boy 2, and then Lindiwe and Selwyn, and then boy 3, girl 1, girl 2, okay, right? So this is the block. A different arrangement would be B1, B2. Swap these ones around, and then we've got B3, girl 1, girl 2, right? Okay, so that's what we mean, right? Whoa. And that, yeah, I'm not actually calculating what these are. 7 factorial is how much? 120 times, I think it's 5040. Of course, things that can be found on the calculator. And then 6 factorial times 2, so that would be 720 times 2, which is 1440. So there are 1,440 ways that Lindy and Selwyn could be together in the photograph, standing next to each other. So therefore, number of arrangements where Lindy and Selwyn are not next to each other will be 5,040 minus 1,440, and that ends up being equal to 3,600 ways. Let's see what the memo has to say for itself. Wait, what was the question? Oh, we need to find the probability. Okay, so the probability of them not standing next to each other is L and S not next to each other. So that will be the number of ways it can happen, which is 3,600, divided by all the possible ways that they could all stand together, right? And that we definitely need a calculator for now. My capacity has been reached. All right, so that's 5/7. Okay, and the memo is in agreement, lacquer.